In section 6.3, we talk about factoring trinomials whose leading coefficient is not 1. So we didn't deal with those at all in the last section. The polynomial of this form is known as the ax squared type because there's going to be some coefficient a of x squared. So that coefficient we're talking about there is not 1. And then the rest of it's normal. We've seen x squared plus bx plus c. You're looking now at ax squared plus bx plus c. Okay, so looking at the strategy here for factoring, assume for a moment that there's no factor that you can take out of everything, so assume there's no greatest common factor. So we want to find the first two terms whose product is a, and the last two terms whose product is c. Right? When I multiply these two terms together, it gives me my x squared term. When I multiply the last two terms together, it gives me my constant term. So I'm looking at two different products here. And by trial and error, then, I need to find the ones that have the mixed terms, the x times constant terms here, that add up to b. Okay, so I'm going to guess based off of the things that multiplied together to get a and the things that multiplied together to get c, and try and find the things that will add up to b. Okay, so this is known right now as the trial and error method. It's the first method we're talking about right here. So we're going to talk about trial and error, and I'm going to show you an example down here of how it works. Alright, for trial and error, I'm going to think of all the things that go into 2. So I know that 2 can be 2 times 1 or 1 times 2. Okay, 15 could be 1 times 15 or 3 times 5. Okay, so I've got a couple of different possibilities here. I'm going to do my ordered pairs, and we know that there are two parts of each ordered pair, some number of x and some constant number. Okay. By the way, I'm also going to use the fact that this term right here is positive and multiply to a positive, so I know I need two positives. So I'm going to go ahead and fill those pluses in right here to help me out. Now for my guesses. I'm going to start with whichever one of these numbers has the fewer options. The first one, right? There's two different choices here, only one choice here. So 2x and 1x are going to be our first choice, right? Now, how many choices do I have for the way I would put something in the second spot? I actually have 2 choices, which is really 4 choices when you think about it, because if I put a 1 here and a 15 here, that's going to be different from putting a 15 here and a 1 here, because it'll be 2x plus 1 is different from 2x plus 15, and x plus 1 is different from x plus 15. It's actually different because the 2x plus 1 is different from the x plus 1. Okay, so let's go ahead and try one of those choices. I just want to say there are 4 things I have to try most before I find the one that works. Okay. Alright, so let me try the 1 and 15 option. Now, to see if this works, we need to find the middle sums, which are the multiples of the x times the non-x and the x times the non-x. We already know x times x works. X times x gives us 2x squared. We already know number times number works. That gives us our 15. So looking at those opposite products of the x times the coefficient, the number, and the number times the x. Alright, so when I add these up, I get 30x. 2x times 15 is 30, plus 1x, and that would give me 31x, which is not what I want, so this does not work. Alright. So we tried 1 and 15, it doesn't work, so let's try 15 and 1. Okay, so I'm going to erase these, but I'm going to leave that there, so that's my evidence that one didn't work. So we're going to try 15 and 1. Alright, so I'm going to try 15 and 1. 2x times 1 is 2x, plus 15 times x is 15x. That adds to 17x. That doesn't work either. We're trying to get 13. Okay, so now I know that this pair, 1 and 15, just doesn't work. So we're going to have to try the other set. We're going to try 3 and 5. Now I don't know yet if it should be 3 first then 5 or 5 first then 3. Okay, so let's try 5 and 3. Okay, that's going to give us 2 times 3 is 6x, plus 5 times x is 5x. That's 11. Doesn't work. I needed 13. I only have one more option to try. I've tried 5 and 3. Now I'm going to try 3 and 5. So 2x times 5x is 10x, plus 3 times x is 3x. That adds up to 13x, and that is what we were trying to get. So that means that the correct answer, the correct factorization of 2x squared plus 13x plus 15 is 2x plus 3 times x plus 5. This is the trial by error method. Alright, and let's try it again one more time. In this next problem, I have 15 and 6. So for 15, I have the options of 1 and 15, or 3 and 5. And for 6, I have the options of 1 and 6, or 2 and 3. Okay, so that's 2 different options for the first one. And for each of those options, 2 more for the second one. But those could be in either order, so that's 4. So 4 options for each of these is a total of 8 different combinations. Okay, we don't want to try all 8, like we had to try all 4 in the one above. So we're going to start by guessing that it's usually not the 1 and 15 or the 1 and 6 option. It's usually some combination of the middle ones. So we'll try those first. When they don't work, we'll start looking at the other ones. Okay, so I'm going to start with 3x and 5x. Then I also need to think about the sign, the positives and negatives that go in here. Okay, this one's another easy decision because it's a positive. It's going to either be 2 negatives or 2 positives, and I can see it's going to have to be 2 positives to add to a positive. So that's nice for us when it adds up, when they're both the same sign, when it's going to add up to a positive or add up to a negative based on 2 of the same sign. Okay, so let's try some of these things here. Let's try 2 and 3. I don't know yet if it's going to be 2 and 3, or if I'd have to put the 3 first and the 2. I'm just guessing here. And we're looking at this. Oops, I drew that line too long. We're looking at this 3x times 3 business, again, because we already know that the 3x times the 5x is the 15. Oh, and my bad, they're supposed to be q's. I'm sorry, I will change them to q's later. And we already know that the 2 times 3 is 6. So the ones I did in red right here are things that we already know, so we're not concerned with those pieces. It's the green ones that we're going to test to see if these ones work to give us that middle value. Okay, so the green ones, 3x times 3 is 9x, and 2 times 5 is 10x. So that adds up to 19x, and that doesn't work. Okay, so we're going to try again. Let's get rid of the 2 and the 3, and let's try 3 and 2. That didn't work. So let's try 3 and 2. Okay, so that would be 6x and 15x. So 6x and 15x, that adds to 21x. I know they're going to be q's in a minute, but 21x. That doesn't work. Okay, so we tried those. Now, there's no point in changing the 3 and the 5 right now because I've already changed the 2 and the 3 and the 3 and the 2 back and forth. I don't need to change both of them. So I leave one column alone, only 2 choices there, and then I have 2 for each of these, so 2, 4 for each one of these that I choose. Okay, so let's try again. We've already so far said that if it's 3 and 5, then it's not 2 and 3. So let's still try 3 and 5, but let's see if the 1 and 6 work. Okay, so 1 and 6. Okay, so let's try. So that would be 3 times 6 is 18, and 1 times 5 is 5, and 18x plus 5x is 23x. That's what I was trying to get here. So my answer, I'm going to make sure I use my q's this time. My answer is 3q plus 1 times 5q plus 6. Okay, that's the set that worked, because when I multiply it together, 3q times 5q is 15q squared. Then I've got 18q plus 5q for 23q in the middle, and finally 1 times 6 is 6. Okay. Alright, in the next video we'll talk about a different method, so let's stop right here on this one.